Welcome to the Binghamton University Rover Team's System Acceptance Review for the 2025 URC competition. We are proud to present our rover, Prometheus. After successfully training and onboarding 60 members throughout the summer and fall, our team has been diligently working to research and redesign our rover to improve competition performance. We modeled the rover closely after our successful entry last year while focusing on iterative improvements to several critical systems.
The drive team upgraded our carbon fiber differential bar assembly using topology optimization and generative design to maximize the rover stability while optimizing mass. Paired with the differential, our welded aluminum rocker bogie suspension keeps the chassis stable under extreme conditions. Driven by 6 brushless motors, the rover comfortably handles rough terrain and can climb slopes up to 45 degrees. Upgrades made to our chassis include additional mounting bars and the introduction of carbon fiber features to facilitate our integration goals while minimizing our total weight. Our new electrical enclosure improves weight distribution across the rover's chassis, further improving stability and enabling the integration of our robotic arm during the science mission.
The electrical team has had several major changes to the way power is supplied and distributed throughout the rover. The rover is now powered by a 24-volt drill battery, which has allowed for improvements in both safety and testing capabilities due to the battery's ease of use. The electrical team continues to make custom-made, hand-soldered PCBs for each subsystem, with the newest addition being a relay board. The relay board uses both mechanical and solid-state relays to control the power distributed to each subsystem, which allows for a controlled startup sequence as well as the ability to power parts of the rover on or off through both an on-the-rover switch and our custom dashboard.
The HREI team has improved on last year's design by focusing on weight reduction, reliability, and ease of operation. Our new base has changed from a planetary to a custom cycloidal gearbox, removing all backlash from our system while also minimizing weight and size. We have also focused on making our arms smarter, incorporating a custom encoder assembly on each joint. This gives us the ability to utilize inverse kinematics, making our arm easier to operate and giving us a visualization of the arm's position at all times. Finally, our modular differential wrist allows us to precisely interact with challenges, and now use our arm in the science mission, quickly swapping our end effector for different missions.
The environmental analysis system's arm-mounted scoop efficiently collects and deposits soil samples for chemical testing and analysis. To test for extinct or extant life, tests such as CO2 detection, nitrate detection, and a fluorescein diacetate hydrolysis reaction will be used. A temperature humidity sensor integrated into the scoop monitors conditions during subsurface sampling. A subsurface sample is then secured in a sealed cache container for further examination. The enclosure was redesigned to accommodate both chassis modifications and simultaneous arm operation. A microscope camera assists in selecting and analyzing optimal sample sites, while a wide-angle camera captures the surrounding landscape, aiding in the identification of water traces within the stratigraphic profile. This comprehensive suite of tests enhanced the team's ability to assess microbial activity.
This year, the software team has made major improvements to our autonomous driving capabilities. We continued using the SAR pathfinding algorithm with the added ability to drive diagonally, allowing for more efficient paths. To detect obstacles as they appear in the path, we integrated a high-precision LiDAR sensor giving us a 270-degree field of view. When locating Erico tags, we used the solve PNP algorithm to determine an estimation of the pose. For detecting objects, we trained a YOLO model to confidently find targets in various backgrounds.
The firmware team has made fine-tuning adjustments to our proven communication system. Our cross-platform control program, the dashboard, connects to the rover over a 2.4 GHz Wi-Fi connection. This year, we're using a high-gain parabolic grid antenna on a rotating base with GPS tracking. Within the rover, a Raspberry Pi acts as a router, handling incoming commands and outgoing data between the firmware and the dashboard. The subsystems are connected to the Pi over USB, with external USB and Ethernet ports for even easier debugging. We use Protobuf to keep packets small and use code generation to keep our data definitions in sync between multiple programs, devices, and languages.
We have developed a versatile rover that highlights our expertise in custom manufacturing designed to excel in each mission while providing an enhanced user experience. All testing is conducted in-house, starting with electrical and mechanical assessments to ensure seamless integration of parts. After any necessary revisions, we fully assemble and test the components and software before incorporating them into the rover. To ensure we are fully prepared for the upcoming competition in Utah, we incorporate rigorous competition-like simulations, including extreme terrain and demanding operational tasks. In addition to the rover's testing, Prometheus and our operators undergo intensive training routines, ensuring they can execute every mission with the highest level of precision. We are excited to return to Utah for this year's URC and are so proud of the incredible work and dedication put in by our team members. Thank you for your consideration, and we look forward to seeing you in Utah.